Contrary to some of the other algorithms, random forest is actually fairly easy to understand. Random forest just merges a collection of independent decision trees to get a more accurate and stable prediction. Random forest is a type of ensemble method. Ensemble combines several machine learning models to decrease both bias and variance. The overall idea here is that multiple models are fit and each key in the different aspect of the data. By combining these models, ultimately generate better prediction together than any of those single models on their own. Let's look at a quick example. We will start with what the training looks like, and then we will look at what it is like to test the model. In training, this algorithm will take in samples from the training data. This is sampling with replacement. That means one single sample is likely to appear in multiple different samples. Then, the next step is to take a sample of features to be used for each of the data samples. In the Titanic dataset, if we have 7 features, each of these data samples, maybe we'll sample 4 or 5 of those features to be used. So now, we have n subsets of our overall data. And those subsets contain both a subset of the rows and also a subset of the columns. Then with the features and the data subset, the algorithm will build a decision tree and try to generate the most accurate results. It's important to realize that these decision trees are all developed on their own. They do not know what the other trees are doing. In summary, we would have n trees that are all built independently on different subsets of data. It's important that these trees are all independent because you want each decision tree to key in on different relationships in the data. This will ultimately generate the best prediction. Next, let's look at how the prediction is generated. Each of these trees represent a fit and concrete model. We would take an example from the test set. Let's call it example A. Example A will enter into all trees that have been built and traverse down the tree based on its features. Then, each of the entry will generate a prediction. Let's look at the most left-hand side tree. Maybe example A stays at the cabin. Then move on to the second layer of the tree. Maybe this person pay the $50. Then, we move on to the third layer, and maybe this person is a female. Based on these features, this model will predict that this person would survive. Now, the splits in the features on the second tree will be totally different. So, it's possible to get a different prediction. If we continue the testing, you will have n predictions for example A, one from each tree. Then the random forest algorithm will basically just aggregate all those predictions together, and based on voting with majority rule, you will make a final prediction. In this case, it would predict that the person survived. When should you consider using random forest? Contrary to logistic regression in SVM, random forest works quite well for problems with both categorical and continuous target variables. One of the major advantages of random forest is that it has an attribute that lays out the importance of each predictor that you're working with. This is really helpful to understand the relationships and the power of the features that you're using in your model. Hence, random forest is great as a quick benchmark model. It tends to perform quite well, it's relatively fast to train, and it's really quite flexible in the type of data that it plays well with. On that note, when you have really messy data with missing values, outliers, and maybe skewed data, random forest deals really well with that kind of data. When should we not use this? While random forest is fairly fast, flexible, and performs quite well, it's not necessarily likely to be the best model for any given problem. If you want a quick model that gets you 90% of the way there, it might be the right tool for the job, but if you really need to get 100% of the way there and extract all possible value out of the data, random forest might not be the right tool. While it's nice to understand the features, and the decision trees on their own can be fairly easy to understand. When you have a random forest of hundreds of decision trees, it can be hard to interpret what's really happening across that entire model. So, if you need to see the details within the model, random forest might not be the right choice for you. In summary, random forest is relatively quick to train, but it's not quite as quick to make predictions. Overall, random forest is a tremendously flexible, relatively fast tool that plays well with different data and can give you relatively good performance.